All right, so here we go. We're gonna continue with Unit 5. We're gonna talk about that locus definition. So I used it a little bit when I was explaining to you guys how to graph on the last page. But so basically what you have, like let's say that we have a quadratic that's centered at the origin. So the vertex is at the origin, and then we can say, okay, it has a C prime length of 2. So the focal length is 2. So that means you're going to go up 1, 2. That's going to give you your focus. You're going to go down 1, 2, and that's going to give you your directrix, which again is going to be a line that goes all the way across. Your locus points are used to help you graph your quadratic. So your focus, if you go twice this length, so 1, 2, 3, 4, you're gonna get a point that's on your quadratic. If you go 1, 2, 3, 4, you're gonna get a point that's on your quadratic. And then you're able to sketch and kind of see what that quadratic looks like. Okay, so 2 focal lengths, so 2C prime gets you here. Well, 2C prime also gets you here. Okay, so it's like this perfect, they're like these perfect points that are equidistant from the focus and the directrix. So it kind of just helps to center everything out. So solving conceptual questions, I have no idea what they could ask for that. But knowing that your locus points are 2 focal lengths from the focus and the directrix. I can't spell right now. Whatever. Again, they're going to be points that are on that quadratic. I don't know how much more in depth they would go, but I think if you knew that, you'd be pretty good. Okay, next thing, explain the relationships between the coefficients in standard form of a quadratic and the features of its parabola. So I'm going to do standard and vertex just so we can do both. So if you have standard form, remember, that's your ax squared plus bx plus c. So the things you need to know that your a value, it's going to always control your concavity. So is it facing up? Is it facing down? And then it also does vertical stretch and vertical compression. Your B value, you don't really do a ton with it. Your B value is what is it moves around your axis of symmetry. So it relates to axis of symmetry. And then your C value is always your y-intercept. If you're looking in vertex form, so remember vertex, that's a x minus h squared plus k. Your a value does the same thing that it did over here. So your a value still does the same thing. Your h value is the x coordinate of your vertex. And your k value is the y coordinate of vertex. So those are just the key attributes that you need to know based on the equation. Okay, next thing, calculate the focal length of a parabola. We've now done this a few times through this review. They've asked about the focus now quite a few times, so I really do think that there's going to be a certain amount of emphasis on that, so make sure you guys know how to do it. So this equation right now is written as y is equal to ax squared, so your a value is equal to negative 1/16. So if you have your A value and you're looking for your focal length, that's going to be C prime is equal to 1 over 4A. So if we plug in what we have 1 over 4 times negative 1/16. Yes, you should be able to do that. Okay, if you need to come off and do it on the side, that's fine, but this is 4 over 1 times negative 1 over 16, which gives us negative 4 over 16, which is negative 1/4. Okay, so this is equal to 1 over negative 1/4. We're dividing by a fraction, so we're going to keep, change, flip. Okay, keep the first one. 1, change to multiplication, flip. This one, that's going to give us negative 4. That's your focal length. So that's how you would do it if you were ever given an equation. If you're given a graph, you need to figure out what your A value is based on your graph. Okay, this is the one time that you really need to understand that your A value tells you when you're moving 1 unit right and left, how far are you moving up and down. So on this one, all right, it shows us if this is our vertex, to get to this point, we go over 1, down 1. That is a negative 1 A value because it's like a slope. So we went over 1, we went down 1. So this tells us that our A value is equal to negative 1. So if we do C prime is equal to 1 over 4 times negative 1, we're going to get that that is equal to negative 1/4. I don't think that they'd ask you to do it off of a graph just because we didn't really cover that in any of the homeworks and things like that, but I did want you to see it just in case. Okay, moving on. All right, this is going to be the last one for Unit 5. So, okay, first of all, let's establish that they are not going to ask you to do a problem like this from beginning to end, because beginning to end would involve you taking the inverse of matrices and doing all that stuff, and that's just not going to happen, okay? But it says that Mark's having fun with bowling balls and clay. He drops balls from various heights and records their speed before impact. Then he measures how far into the clay the ball went, okay? So it starts with write an equation relating the speed v to the depth of the indentation. So your x value is here, your y value is here, okay? When you're given a big table of values like this, all right, you can choose any x1, any x2, any x3. You just have to be consistent, and those have to be your y1s, y2s, and y3s. So if I'm going to pick the easiest numbers. Well, the easiest numbers would be 5, 10, and 15. If you pick different numbers, you're going to get the same equation, just maybe a little bit off because this is like a regression, so it's not like a perfect thing every single time. So what I do think you could be tested on is they could have like the setup, and you have to know how to set up. So your setup here is going to be, this is your x1, so this is your x squared column, and then you have your x column, and then you have your 1 column. You have to know that you take the inverse of that and you multiply it by your y's, and then it gives you back your A, B, and C values for your equation. All right, so if I picked these, 5 squared is 25, then 5, then 1. The y that's associated with that is 0.3. Then we go on to the next one. 10 squared is 100, and then 10, and then 1. And then that number is 1.2. And then you go on to the last one. 15 squared is 225, and then 15, and then 1. And so this number is 2.7. I could very much see them asking you to set it up. So understanding, like if they gave you that this was 10, you'd need to understand that this would have been 100. If they gave you that this was 2.7 but left these blank, you would know to go down to the graph, okay, 2.7, that's associated with 15, and then 15 squared is 225. That I could see them asking you, but they're not going to ask you to do everything that goes into it. So if you were to do this in the calculator, all right, however you like to put in your matrices, I do the menu 711. I need a 3 by 3. And so then I fill in. So 25, 100, 225, 5, 10, 15, 1, 1, 1. Making sure that you take the inverse of this. So not just keeping it as is. And then we're multiplying that by another one. I need it to be a 3 by 1. And those numbers are 0.3, 1.2, and 2.7. This was number 2 on y'all's homework for 541. So if you hit enter, you get this. That means that my equation for this, my A value is 0.012, and then 0, and then 0. Okay, so if I were to write the equation, I would say that y is equal to 0.012 x squared. So actually a really easy equation once you get going. If the ball is going 20 meters per second, so this is an x value, how far into the clay should it go? So you would say y is equal to 0.012 times 20 squared. So 0.012 times 400 would give us 4.8 meters. Make sure that you are putting a label if it's real world stuff. And then the last one, how fast would the ball be going to make it a 7.5 meter impact? So this is a y value. So 7.5 is equal to 0.012 x squared. So I would start to solve for x. I would divide by 0.012, divide by 0.012. And then that would give me 625 is equal to x squared. If I square root and square root, you have to account for the positive and the negative, but because this is how fast, you don't go negative 10 miles an hour. So we just need the positive. The square root of 625 is just going to be 25 is equal to x. So that means it was 25 meters per second. If you look back and you were to plug these in, so this is filling in this value right here, and this is filling in this value right here. Those make sense in your equation or in your table, so you can kind of use that as a check too. All right, I'm going to pick up with Unit 6 in the next video, so if you need that one, make sure you just hop on. All right, see y'all.